Welcome back, everyone. In the last session, we have overviewed the concepts of SQL. Today, we'll dive in one of the most fundamental yet powerful concepts in SQL, working with multiple tables using join and union. These concepts allow us to retrieve and manipulate data efficiently when dealing with the relational database that stores information across multiple tables. In the real world application, data is rarely stored in a single table. Businesses manage multiple datasets such as customers, orders, employees, and inventory, which are interconnected. Understanding how to retrieve meaningful insights from these datasets using joins and unions is a crucial skill for database management, business intelligence, and data science. Now that we understand why multiple tables are essential, let's break down how to retrieve data efficiently. There are three key components: single table queries, multiple table operations, and ordering results. Single table queries. A basic SQL query retrieves data from one table, which we have discussed in the previous session. For example, we select a column list from a table, have a where condition, and then order by the column. So this one is getting all the customer names in an alphabetical order. If we have select column customer name from customers, order by customer name, but in the real world is that normally we will have more than one table. So this is where join and union come in. Multiple table operations. Join will merge columns from related tables. Union will stack rows from table with the same structure. For example, we can union like the customer name from 2025 year and then that of 2026, you stacking the customer information from two different years. And finally, it's ordering result. SQL sorts results ascending by default. If we use descending, then it will give us like descending order. For example, if we say that select a customer name from a customer table, ordered by the sign up date descending, in that way that will sort organize meaningfully by so basically the latest sign up date, those customers will be put on the top. So let's talk what is a union. Union combines results from multiple select statements that will remove duplicates by default. The syntax will be each select must have the same number of columns and matching data types. The result union will remove duplicates. If you want to keep the duplicates, then you can use union all. So for example, if you have customer name from customer 2024, union all, select customer name from customers 2025. In this way, if the same customer exists in both 2024 and 2025, the result will keep the duplicates over there if you have the union all instead of a union. So for join, it's different. Join is combining columns from two or more tables using a related column. Example, we retrieve customer name in their orders. So in this way, we'll using customer table joins order table, using their primary key and a foreign key. For example, if we have customer ID in the order table as a foreign key, then you merge that by joining the primary key and foreign key. The syntax would be like join connects table using R1 join R2 on primary key equals to foreign key. This will create a new virtual table by merging columns from a related table. Next, we will compare union versus join. So what's the difference between the two? Union acts like a Boolean OR that combines results from multiple select statements. Select rows from multiple tables. Rows must have the same structure. And merging similar data, example, combining customer list from different years. While join is creating a Cartesian product, merge columns instead of rows. Projects column from multiple tables used for relational queries. Linking tables using primary key and foreign key. Like we said in the previous example, where we can merge customer and order in terms of the primary key and foreign key as a customer ID. So when do we use union and when do we use join? Union is used when tables have a similar structure or attribute. For example, we want to build a directory of the school, merging student and faculty tables in a directory. So in this way, what you can do is you just select name, email from a student table, and then union, select name, email from faculty table. So you have to make sure that you have exactly same column name and column type from two tables, and then union them together. Only when if you want to keep the duplicates, then you use union all instead of union. While join, we use join only when tables are linked by primary key and foreign key. The example can be connecting students and a course to track enrollment. In this one, we will join student and a course on the enrollment, for example, using the enrollment course ID and the course ID to merge them together. So there are more examples. So when we use table have similar structures, same column and data type, we can use union. For example, here, student and faculty have a similar structure. What we can do is that select faculty name, select first name, last name, address from student table, and then union select first name, last name, and address from faculty. Then in this way, you can combine the data from student table and faculty table. And then we use join when the table have primary key and a foreign key relationship. For example, student and enrollment has a relationship which is student enrolling in course, and class have relationship with enrollment as well, or class has a relationship with the faculty where it's about instructor assignment. So in this way, you always use that select one table, join another table, and on by the foreign key and primary key to merge them together. Here we can see a detailed syntax here. For example, union, you can have select columns from table 1, and then union, select columns from table 2. And the syntax for join is you select the columns. It can be either from table 1 or table 2, and then inner join table 2, where on the table 1 primary key and the table 2 foreign key and link them together. And also later we will also learn there is alternative join. Instead of using join and on, we can also just select from table 1 and table 2, where table 1 primary key equals to table 2 foreign key. So the join and the and the where condition work similarly. In this slide, we are renaming the columns. So why do we rename columns? This will ensure consistency when combining different tables that can help standardize columns name across multiple data sets. For example, in this example, we are change the name of table 1 column's name as name 1 and table 2 column's name as name 2. And then we change the column's name for table 2 and table n as well. And then you union them together. What you select, the column name will be name 1 and name 2. So by this kind of renaming, that ensure clarity and prevent errors when merging data. So this will make sure that each select must have the same number of columns and matching data types as well as columns names. Another example, we need a unified directory combining faculty and student records. Union merge their details into a single list while ensuring consistent columns names. So here we can see the rename. So basically we have select first name, last name as name, and then we also have rank as status, and also put faculty as member for all the records from faculty table. And then it will union first name and last name as name, and then status, and also student as a member. So basically we put the student as a value for the member for all the records from student table. And then we order by member, so that will be ordered by the groups. So union efficiently merge different but structure similar table, making it useful for directory and reports purpose. So for Cartesian product, that pairs every row from one table with every row from another table. The result size will be R1 times R2, multiplying the numbers of the row in each table. A lot of time it's not meaningful unless filter is by condition by where or join. So for example, if we have select first name, last name, and from faculty and student, this will pair every faculty member with every student, creating a massive data set, often unintentionally due to missing join condition. So we have to avoid this kind of Cartesian products unless it's needed. Always use join condition to prevent unintended row explosion. So there's an example. The Cartesian product returns all possible combination of rows from 2 or more tables. So when you merge this without the join condition, this will create a random unrelated row combination that don't represent valid relationship. So like in this case, the faculty member can pair with a student that they don't advise or don't have a relationship with at all. So the meaningful way to deal with this is that we need to have a valid relationship exist where rows are logically connected, like a student and their actual advisor. So adding a join condition prevents this spurious tuples. Again, this kind of Cartesian products are the basis for join operation. When filter join on, they generate meaningful relationships. So like in this case, if we want to get a meaningful relationship, what we can do is that we select faculty ID, name, student, or advisor from the faculty table and the student table, but we need to let faculty join student table on faculty ID equals to the student table advisor. So we can merge the two tables by primary key and foreign key. So in this way, we will filter with the join on. We will get the meaningful relationships data. So use Cartesian product with caution. Always apply condition to avoid meaningless row combinations. So let's talk about inner join. An inner join returns only matching rows from both tables based on common key. Rows without a match in either table are excluded. So the syntax here can be select field list from table 1, inner join table 2 on the table 1 primary key equals to table 2's foreign key. So primary key in one table connects to foreign key in another. So the example here, select the first name and last name as student, and then the one that from faculty name as advisor, from faculty inner join student on faculty ID equals to student's advisor. This will retrieve student and their assigned faculty advisor. So we use inner join when you only need matching record from both tables. So there's more example. Their inner join returns only matching rows where faculty ID and faculty matching advisor and student. That ensures valid relationships between student and advisor. So in this way, every record are meaningful. The rows are correctly link students to their actual advisor. For example, Sunny, which is faculty 1111, is correctly linked to Mary, Sweetie, etc. Rows that don't make logic sense without a join condition, all faculty would be paired with all students, causing meaningless results. But with this inner join condition, we will take only like when the two sides are matching. So this will filter only valid relationships, avoiding meaningless data combinations. So there are two ways to do the inner join. The number one is that you use a join keyword to explicitly define relationships. It's more readable and structured for complex queries. So the syntax here will be like select field list from table 1 inner join table 2 on table 1's primary key equals to table 2's foreign key. So like when we merge the join the advisor table and faculty table and the student table, where we can use the faculty ID equals to student's advisor ID. In this way, we will pull out the student's name and their advisor's name. The where clause syntax also works. That is using the where clause to filter results after listing table. It's older style, but functionally equivalent. For example, in this case, we can say that select field list from table 1, comma, table 2, where table 1's primary key equals table 2, the primary key, foreign key. So both way work, but in order to be like clarity, to have clear and have clarity, inner join is preferred. But where-based join work similarly, even though the inner join is more readable. In relationship database, a lot of time we can also join multiple tables instead of just two tables, because the data can often spread across multiple tables. If we need to join more than two tables to get complete information, we can do the similar things where we can just inner join one table and then inner join another table, but we need to add the on condition over there to filter out by the primary key and the foreign key. The alternative approach is that using the where condition. Similarly, you can use like from table 1 and then like comma and then table 2 and table 3. Just separate them by comma, and then you have a where condition where you can linking those tables by the foreign key and primary key. So in this way, we can, when we join multiple tables, that helps to retrieve complete and meaningful data from relational database. In this session, we only talk about inner join, where is that all the records have to be matched on both sides, left and right. And there, in the later session, we will talk in more detail, talking about left join, which includes the unmatched record from the table on the left, or while the right join includes unmatched records on the right. So we will talk more detail in the next session. See you next time.